Now, what was the example that I told you that is something that you would generally use transparent firewall with? Remember up front I told you that? MPLS. Now, when a packet comes in, which is an MPLS packet, what does the packet look like? Let's take a look at an IP packet first. What does an IP packet look like? What does it have in the upper layer headers? So let's say it's an IP packet going to a web server. On the transport layer, in the destination port number, what does it have? Source port is random. Destination port is what? 80. This is at the transport layer, agreed? What's the purpose of this destination port? What does it do? Remember your OSI reference model, the boring stuff? Yeah? The purpose of the destination port, which is a layer 4 header, is to tell my PC which upper layer application do I want to send the traffic to. And the port number is used to identify at the transport layer the application layer protocol. So 80 does not reside at what layer? At the transport layer. It resides at the application layer, but it's used by the transport layer so that it knows what upper layer protocol to send it to. You guys understand that, which is web. How about from the network layer? So this is the transport layer, this is the network layer, this is the application layer. How about the network layer? Who does network layer send the packet up to? The network layer, what does it send the packet up to? Transport layer, but transport layer, what transport layer? Isn't there a protocol over there? Either TCP or UDP, correct? In my case, TCP, but no, it could have been UDP as well. So how does the network layer know that the next layer that it needs to send the traffic to is TCP or UDP? Does it put that in the header? So you would have normally what? What you guys are aware of, source IP, destination IP, but it also has what? A protocol number. The protocol number in case of TCP is 6. So if I'm sending it up over here to the transport layer, I'll either send it to TCP or UDP. You guys agree? This is 6 and this is 17. So in your packet, you're going to see a protocol of what? 6, source IP, whatever, destination IP, whatever. So how did the transport layer send the traffic to the application layer? By utilizing what? What did I utilize over here to send the traffic from the transport to the application? It was the port number, agreed? What was used to send it from the network layer to the transport layer? It was the protocol number, right? Now, similarly, what is used at the data link layer? To send the packet to whom? To the network layer. So this is your data link layer. Does the data link layer just send the packet to the next layer and say catch? Or does it send it to a particular protocol? So this red is your network layer header. This blue is your transport layer header. Let's put the green as layer 2. So on every packet at layer 2, it needs to identify the next protocol that will process it. And that is called an Ethertype. So over here, you're going to have a Ethertype. On this layer, actually, you have other things as well. Do you guys remember the data link layer has 2 sublayers? What are the 2 sublayers of the data link layer? Remember, data link was broken down into 2 sublayers. The LLC layer, the logical link control layer, and the MAC address layer, the MAC layer. The MAC layer, you know, is source MAC and destination MAC. Okay? That is this over here. How about the LLC layer? What is that used for? The purpose of the LLC layer is to identify the next protocol to handle. And that's Ethertype. So the Ethertype identifies the protocol at the top layer. You might say, well, it's always going to be IP, which is true in today's day and age. It wasn't always like that. You used to have IP, IPX, AppleTalk, different protocols residing at what layer? At the network layer. So the data link layer, to identify the upper layer protocol to send it to, it would use this field called the Ethertype. You get my point? So for IP, the Ethertype is 800. So when it got the packet, it knew that it was an IP packet will forward it. When they came up with MPLS, MPLS resided between layer 2 and layer 3. Okay? So you had your layer 2 header, which had the source MAC, destination MAC, your the MAC sublayer. You had your Ethertype over here. And then the MPLS label was over here. So if it's an MPLS packet, layer 2 is not going to forward it to IP, it's going to forward it to what? MPLS. So MPLS had its own Ethertype. So when the packet came in, the Ethertype is the one that specified, hey, the next one is MPLS, it's not IP. But normally it would have been what? IP. Or IPX. IPX has its own Ethertype, I think it's 8167. You get my point, you guys understand that? And why am I stressing that? Why am I going back to CCNA? The only reason I'm doing that is by default, you need to understand the flow. The only Ethertype that is allowed by default to pass through your transparent firewall is if the packet has an Ethertype of 0x800, only IP. So when it inspects a packet at layer 2, it only allows IP to go across. It doesn't check anything else. If it's 0x0800, then it passes it to layer 3. That's where the ACLs come in. But at layer 2, if it was not 0x0800, it would completely block that packet by default, regardless of the layer 3. It would block it at layer 2. Understood? That's the characteristic of an ASA firewall. So the only Ethertype that's allowed by default is 0x0800. That's IP. Pure IP packet. It cannot be an MPLS packet. So let's say I was running MPLS between what? R1, R2, and R3. Okay. When the packet came in over here, the packet would have an Ethertype of 8847, not 800. That packet would be dropped. So if you're running a non-IP environment, any Ethertype that you're running, you need to allow it explicitly. In what? In an ACL. It's a special type ACL. It's a layer 2 ACL that only pertains to what? Ethertypes. Okay? So let's do a small write-up about that, and then we'll implement it. Ethertypes. By default, the only traffic that is allowed through the firewall is IP, which is what? Ethertype 0x0800. Before a packet gets checked against the ACL, the firewall checks what? The Ethertype. Okay? Even if you have a permit IP any, but it's the Ethertype is not 0x800, it doesn't get to the ACL, it just blocks it right there. Actually, I should put this. Before a packet gets checked against the ACL, the firewall checks the Ethertype. By default, the only traffic that is allowed through the firewall is IP, Ethertype 800. Any non-IP Ethertype needs an explicit allow in an Ethertype ACL on both interfaces, in all directions. Okay, so let's say I was running MPLS. How would I do it? Access-list, give it a name, whatever you want to call it. I'll call it ABC so that you guys know it's just a name. Ethertype. So when I say Ethertype, it knows it's a Ethertype ACL. Permit 0x8847. You get my point? So I'm allowing 8847. The thing is, you know how an ACL normally works? You have a permit and deny any. Yeah? IP cannot be blocked. So you don't need to specify 0x0800. Even if I say permit 8847, it is in addition to IP. It's a little different the way the Ethertype ACL works. Access-list ABC, I don't need to do that. Now I need to apply it. Access-group ABC in interface ABC. I need to do the same thing on the other interface as well. So it needs to be applied on both interfaces. So this is not saying only allow Ethertype 8847, that is MPLS. It is basically saying what? Allow MPLS in addition to IP, because IP is something that you cannot block. If you're blocking all IP, essentially, what are you saying? It's just non-IP traffic that you're allowing. So they don't let you do that. You want to block IP, you need to do it at a layer 3 ACL level. Good so far, guys? Everybody okay with this? Copy. Let's go and paste it over here and see if it takes. Now, I want you guys to see that. Normally, what do you know about an ACL? How many ACLs can you apply on an interface in one direction? One, right? One per interface per direction, right? Per type. So if you take a look at your show run access-group command, you'll notice that ABC and outside are both applied in the same direction on the same interface. Because these are two different type of ACL. This is an Ethertype. The other one is a normal IP ACL. Got it? So this is what you would need to do if you wanted to allow MPLS traffic to go through the firewall. Doesn't mean it's not checking the layer 3 header. It's just saying, I want to allow MPLS. So once the first check takes place, then it goes and checks the layer 3 ACL. But it starts by checking at layer 2. All right? You guys good with this Ethertype? And if you take a look at the three things for the transparent firewall we had to cover, we have done that. All good, everybody? Multicast should be allowed on inside and outside, correct. You take a look at your ACL for that as well. I done that as well over here. Show run. Access dash list. This is your multicast on the outside. On the inside, I have the permit IP any that takes care of the multicast. AC, you good with that? Any questions, guys? Yes, that's the, it's like saying permit EQ 80. It knows 80 is, what do you call it? www. See this over here? I said EQ 23, it converted to telnet. If you do not use any, then no other traffic will be allowed besides the one in the ACL. Like normal ACLs, yes, if you have one permit statement in the ACL, the rest of the traffic will be blocked. So the other thing that you could have done, which I also alluded to, is you could have allowed what? UDP, any host 224.0.0.9, EQ 520, and after that you could have said permit, this also permit, what do you call it? TCP, any, UDP, any. So if you didn't want to do any, you could do this as well. But you need to make sure that you allow the rest of the traffic, because otherwise the deny IP any would block the rest of the traffic. Got it, Khan? All good then?